Hello, in this video we'll show you how interrupts work in the Qt-SPIM tool. This is followed by the analysis of two laboratory exercises with the use of interrupts. In the first program the user inserts the time into milliseconds, so that the program is interrupted and the appropriate message is printed on the screen. As a first step, in the main program we activate the first bit in register 12, thus triggering the interrupts. Then, after we have activated the interrupts, the user reads the value for time, passing it to register 11, which is responsible for value compared against timer that causes interrupt when they match. We also give an initial value of 0 to registrar 9, which has the role of time counter. In order to handle the interrupts we must move to that address within the operating system kernel. Applying the appropriate standardization we keep the values that are useful to us in the available kernel space and recover them in the end. We copy the credential value 13 that contains the cause of the interruption in our program. Bits of 2 through 6 indicate the cause of the interruption, in which case these 4 bits have the value of 0, so it is a break caused by the hardware. We then check if the register bit 15 is enabled, that is, the value of 1. If yes, then it is a time-dependent interruption. Thus we reset the register 9, which measures time and prints the message we have defined. Finally, we retrieve the values stored in the memory and via the arrayed return exception command, return the status register of the kernel registers to its original state and return to the interrupted program. In the second program, through the receiver control the user enters characters from the alphabet and through the Caesar method is encrypted and printed on the console with transmitter data. The key used in the encoding is indicated in the data area in the main program. In order to activate keyboard interruptions, we go to that address and give the value 1 to the second bit. Then we initialize to register 12 with the value 1 the bits 0, 11, and 15, so that we activate the interruption in our program every time the user enters a character in the receiver control. In the core area, we keep the values of our registers that are useful for us and we would like to keep it. We check the bits 2 of up to 6 of the register 13 that contains the cause of the interruption of our program. Since this is a break due to hardware, we check if it is a break caused by the keyboard. Now that the interrupt has come from the keyboard, we check if the receiver control is ready, that its second bit is on, and then we check whether the transmitter control is activated by its first bit. Then we read the character from the receiver data and through the appropriate checks we encrypt the inserted characters. By Caesar's method we store them in the transmitter data and print them on the screen. When the user gives any character outside the alphabet, the appropriate error message is displayed.